Assalamu alaikum. Welcome to Mathematics with Shahab Yaqub. In today's class, we are focusing on binomial expansion of P1, and this is the second part of the lecture. Now, there are two things that I'll be focusing on. The first thing is about the concept of NCR. How can we evaluate NCR without a calculator? Now, this is the official formula that is for NCR. So now let me just give you some examples. We know that NCN equals to 1. We know that NC0 equals to 1. And we know that NC1 equals to N. Now, these are three very, very important results that is of use to us. NCN is 1, NC0 is 1, NC1 is N. Now, let me evaluate NC1 using this. So if I write NC1, that is n factorial divided by n minus 1 factorial, and this is 1 factorial. So technically, n factorial is n minus 1, n minus 2, and so on. And n minus 1 factorial is n minus 1. It reduces by 1, n minus 2, n minus 3, and so on. So if I do the division, this part is exactly the same thing as this part. So what am I left with? I am simply left with n. That is one way of doing and proving this thing. Now let me prove it by writing a value 5c1. That is 5 factorial divided by 5 minus 1 factorial and 1 factorial. 5 factorial is 5, 4, 3, 2, and 1. And 5 minus 1 is 4 factorial. That is 4, 3, 2, 1. So what am I left with? I'm left with 5. That is the first and foremost thing. Now, similarly, let me evaluate 5c2. That is 5 factorial divided by 5 minus 2 factorial, 2 factorial. That is 5, 4, 3, 2, 1. 5 minus 2 is 3. 3 factorial is 3, 2, 1. 2 factorial is 2 into 1. So let me simplify it. 2 into 1 cancels off with 2 into 1. And then this are 3 and 2 and 1. This is 6. And this 3 and 3 cancels out, or I can cancel out this 2 and 2, 5 into 2, that comes out to be 10. Now, that is how this calculation is done. Now, why am I focusing on something that we have studied in S1? And the reason is there are some questions like these in which I need this concept. So let me tell you the easier version of this. So let me add a page over here. And let me tell you the very, very easy option how to evaluate these things. So we will write 5c1 is basically 5 over 1. Just follow this pattern. 5c2, that is 5. It reduces to 4 and then 2 into 1. 5c3, that is 5, 4, 3, 3, 2, 1. Basically, what I'm doing is that underneath, that means the denominator, I'm writing 1 factorial. If 2 is over here, this is 2 factorial. If 3 is over here, I'm writing 3 factorial. Since there are 3 terms, therefore, I start with 5, I reduce by 1, I reduce by 1. Similarly, this is 2 factorial. I start with 5, I reduce it by 1. This is 1 factorial. I just write 5. And that is a very easy way of evaluating. This is 5. This is 20 over 2, which is 10. 5c3, that this 3 and 3 cancels out. 4 and 2 cancels out, giving us 2 at the top. So 5 into 2 is 10. So now that is how these things are calculated. So now how will I use this over here? Let's have a good look at this question. Given that the expansion of 1 plus ax power n begins with this thing, and these are the first 3 terms. So let me underline it. The first term is 36. The second term is 36x. The third term is 576x squared. These are the first 3 terms of this thing. We need to find the value of A. We need to find the value of N. Now, what we do is that, let me write 1 and let me make it a bit thinner. So this is 1 plus AX raised to power of N. In the words, in the symbols of A and N, I'll write NC0 AX power 0. This is NC1 AX power 1. This is NC2 AX power 2, and so on. There are many more terms because we don't know what's the value of N, but the first three terms are this. So now over here, we know that NC0 is 1. So this is 1. NC1 is N over 1, which is simply 1, which is simply N. And NC2, what is that? That is N minus 1 over 2 into 1, 2 factorial. So let me write these things over here so that life becomes easy. And let me write in the symbolic form. NC1, we know it's N over 1. NC2, just like that, N minus 1, 2 factorial, 2 into 1. NC3, there are three terms related with N minus 1, N minus 2 over 3 into 2 into 1. So we just need the first two. Now, what about this? AX power 0, that is simply 1. AX power 1, it's simply AX. AX power 2, the whole thing, that is A square, X square. Now let's simplify and write it down. So this is, the first one is 1. This is N A X. And this is N minus 1, 2 into 1. And this is A square, X square. So let me just write it properly so that everything is in one line. So therefore, this is 1 plus NAX plus this thing. Now, let's do comparing coefficient. First of all, this is also 1. So the first term is 1. This is 1. No big deal. Now, the second one, that is 36x square, 36x, that is equals to NA. And the other one, 576x square, that is equals to all this thing. Now, if we talk about the coefficient, how would we work it out? So let me just focus on the coefficient. Let me erase this. Over here, 576, that is the coefficient of x square. Over here, 36x, that is the coefficient of x. So what I'll do is this. I'll say coefficient of x, that is NA equals to 36. That is equation number 1. And I'm talking about coefficient of x square, that is N minus 1 over 2, this and A square. That is equals to what? That is equals to 576. That is equation number 2. So now what we do is that we have to solve this simultaneously. And what I'll do is that I'll make, let's make A the subject. So A is 36 over N. And let me plug it in this one. So therefore, this is 36 over N, the whole thing square. This is N minus 1. Grab your calculators. I'll be needing your help. And this is equals to 576. So let me break it up. Let me first open up the bracket. N minus 1, 2, and this is 36 into 36. Let me write it twice. 36, 36. This is N, this is N, this is 576. So first of all, what I'll do is that I'll cancel off these N's. And let me take this N to the other side. Let me cancel 2 and 36, which is 18. And I'm also grabbing my calculator. You should also double check. So first of all, I have 18 into 36, that is 648. So this is 648. It's multiplying with N minus 1, that is 648, N minus 648. And this is N into 576, 576N. This is 576N. So now 648 minus 576, that is 72. So this is 72N is equals to 648. So therefore 648 8 divided by 72. This comes out to be 9. The value of n is 9, and the answer is written right over here. N is equals to 9. All good, all clear. Now, what is A equals to? A is 36 over n. So A is 36 over 9, which comes out to be 4. Again, the answer is correct. All good, all clear. So that is how this particular question is done. So this is worked example 1. That is how it's done. I have another example for you that you can try out now. I think it's a good time. So let me just pause the recording so that you have the first-hand experience of trying out this question. Let me pause the recording. So now let's solve this particular question more or less on the same pattern. So now it says, given that the left-hand side is identical to the right-hand side, that means the first 3 terms, find A and N. So I'll write 1 plus ax raised to power of n, just like before, nc0, ax raised to power of 0, nc1, ax power 1, nc2, ax power 2. We know that nc0 is 1, nc1 is n, nc2 is n minus 1 over 2 factorial, which is 2 into 1. Over here, this is also 1. This is ax. This is a square, x square. So now I'll say coefficient of x. Over here, it's negative 12. So this negative 12 is equals to na. X is the variable. So the coefficient, let me highlight it. That is n and that is a. So na equals to negative 12. That's the first thing. And if I talk about the coefficient of x square, so I'll be writing it over here. So let me write over here coefficient of x square. What's the coefficient of x square? That is 63. And that equals to n minus 1, 2 into 1. I can simply write it 2. And then this is a square, and that is the equation number 2. It's the same strategy as before. From the first equation, make a the subject, that is negative 12 over n. Plug it in over here. So therefore, this is 63. This is n minus 1. This is 2. A square is negative 12 over n. This is negative 12 over n. Let me cancel out these two negative. That's the first thing. Let me cancel out 2 ones are, 2 6 are. And let me also cancel out this n with this n. So therefore, this is 63. This n will go to the other side, 63n, n minus 1. That will be multiplying with 6 into 12, which is 72. So this is 72n minus 72. This is 63n. So therefore, 63 minus 72. How much is that? That is 7 into 9. Negative 9n is negative 72. Therefore, n comes out to be 8. That's the answer right over here. When n is 8, a is minus 12 over n, a is negative 12 over n, negative 12 over 8, which comes out to be negative 3 over 2, and that is the answer. So it's all double checked. So I hope you have understood this simultaneous type question thoroughly and very well. Now, the next kind of question, what is it about? The next kind of question is about a particular term. The first term has an x, the other term also has an x, but it's in the denominator. And all these questions that you see over here are following this pattern. So if you see questions like these, first of all, they are asking for one particular term. So the expansion is of the form, let me write it down. That is a plus b raised to power of n, because the first term is not 1. Let me write down the particular term formula. What is that? That is NCR, b raised to power of r, a raised to power of n minus r. So the first term, let me highlight it. This is a. So this first term is a. And let me just highlight a little bit on the side so that the minus sign goes on the other side. This is b. Therefore, this minus and this 3 over 2x, that is b. And over here, what is in? The value over here is 6. Now, when we have such a bracket, such a binomial, in which the first term has an x, the second term has an x, we don't know how the powers will change. So in order to find the term independent of x, and that is something very, very common that they ask. So when they say a term independent of x, that means a constant term. Remember this terminology, it's widely used in P1. Term independent of x, that means the constant term. Therefore, the power of x is 0. So we are looking for the term in which the power of x is 0. We don't know what is the position of the term in the series. So we apply this method that is called the three-step process. And let's learn how to apply the three-step process the way that I explain it. So now what we do is that, first of all, step number 1. Observe these steps very, very wisely. Write down the formula, that is 6CR. We don't know the value of R. We have A, we have B. B is raised to power of R. A is raised to power of N minus R, which is 6 minus R. That is the first thing. So this is negative 3 over 2x raised to power of negative 1. So let me highlight over here. This blue thing that I just highlighted, negative 3 over 2x is taken up, that is x power negative 1. So let me write it like this. So x power negative 1, I'm focusing on this. The constant definitely is there. And then what is A? A is x. So let me write x over here. That means x has a power of 1. And this is what I'm focusing on. Again, let me highlight. So this is x power 1. Now, x power 1 is raised to power of 6 minus r, and x power negative 1 is raised to power of r. So now go to your WhatsApp and let me write down this thing. That is first step. So now is it all good, all clear? This is the first step of the three-step process. Very simple step, but I want your input at every step. Okay, I sent the message twice in one of the groups. Let me send it to the other one. Hold for a second. Okay. So now this is group 2, group 1. Okay. Now, the first step is basically writing it out. It's a very easy step, but it's methodical. So you have to follow every step. This is NCR. N is 6. R is unknown. So the whole objective is of this three-step process is to find R first. So now 6CR, x raised to power of R raised to power of 6 minus R. Negative 3 over 2, x raised to power of negative 1 raised to power of R. So step 1, write it out. Now, step number 2. What do you think? Step number 2. It's all about the powers. So listen to my words. The pen is skipping. Gather powers of x and equate it to the power of required term. So that is the main thing that we need to do. Now, when we talk about gathering power, so I have this little bit red color multiplying with this something red. I have the blue color multiplying with the blue, and I'm equating it to the power, which is x power 0. So I'm equating it to the green thing. So basically a plus sign over here. This one is multiplying with r. This negative 1, not r, my bad, that is multiplying with 6 minus r. And this negative 1 is multiplying with r. We add it, we gather powers of x, and equate it to the power of required term, which is 0. So now that's the second step. So this is 6 minus r equals to 0. Negative 2r is negative 6. Therefore, r comes out to be positive 3. That means technically the fourth term is our required term. That will be the constant term. That will be the term independent of x. So now it's the second step. Now step 2, that is this thing. Is the step 2 all good, all clear? Some people are a little bit slow in acknowledging the message. I need a little bit prompt, fast, quick response. Okay, better than before. So now let's look at the first step once again. I'll be doing 2-3 questions and then I'll ask you to try out one question. So just hold your horses and sit back and relax. 6CR, NCR, b raised to power of r. You have to take this x up before you apply this method. And a raised to power of n minus r. So write it out. Gather powers of x and equate it to the power of required term. Let me just check one thing. That is, I think, did I mute you all? Because I just heard a voice. Okay. So now, all good, all clear. The step number 2, gather powers of x, add it up and equate it to the power of required term. We need the term independent of x, which has a power of 0. 1 is multiplying with 6 minus r, minus 1 is multiplying with r. According to rules of indices, r is coming out to be positive 3. Now, just a double checking thing. This r can come out to be 0 or any positive integer, because 0 means first term. R is equals to 0 means first term. R is equals to 1 means second term. R is equals to 2 means third term. R is equals to 3 means fourth term, and so on. Or R can be 0 or any positive integer. R cannot be negative. R cannot be a fraction, because R tells you the position of the term in the series. All good, all clear? And now here comes the very last step. That is step number 3. The whole objective was to find this particular term. So go to step number 1 and place R where it belongs. So I'll write this thing. That is 6C3. And then that is negative 3 over 2x. Now x can relax and go downstairs. Raised to power of r, which is 3. And then we have x power 1 raised to power of 6 minus r, which is 3. So now we know that 6C3 is 20. X raised to power of 3. Negative 3 raised to power of 3 is negative 27. 2 raised to power of 3, that is 8. And this is 1 over x cube. Now double check. This x cube over here is cancelling with 1 over x cube. That will give me the constant term. So now let me simplify a bit. That is 20. No, not this thing, the other marker. This is 20. This is 8. This is negative 27. So 4 2s are, 4 5s are, 5 into 27. How much is that? That is 5 7s are 35 and 100, negative 135 divided by 2. So that is 135 over 2 is 67.5, and that's how this is done. Now, a word of caution. That word of caution that I will be again informing you near the exams, that is, mark scheme is not responsible for telling you the number of steps. Mark scheme, just go ahead and check the answer. That is all good for that. But the number of steps that will be provided by me or your teacher. That will tell you exactly the number of steps that needs to be done. Over here, I am telling you that this is a 3-step process. Do not skip any single step. That's how things are done. So now just double check. Okay, all 3 steps are done. So now, is this all good, all clear? Just acknowledge this thing. The first, write out the formula. Second, gather powers of x and equate it to the power of required term. Third, what is that? Once you find the value of r, which can be 0, that means it's the first term, which can be any positive integer, but it cannot be a fraction, it cannot be a negative integer. So now once that is done, you place r where it belongs, these 3 places, evaluate, simplify, double check. Before the examiner checks, you have already checked your working. And this is the answer, that is the term. And that's how the first question is done. Now, this one is also about independent term, independent of x. Let me skip this one. Let me go to a one in which something else is asked, such as this. Now, over here, let me highlight this. That is the A. This one over here, that is B. This one over here, that is N. So now it will be quicker this time. So the particular term is NCR, B raised to power of R, A raised to power of N minus R. So step number 1, N is 5. That is 5CR. The second bracket, 3x square raised to power of R. First bracket, x power -1 raised to power of 5 minus R. So let's focus on the powers. This -1 will multiply with 5 minus R. This 2 will multiply with R. That is step number 1. Step number 2, gather powers and equate it to power of required term. -1 multiplies with 5 minus R and 2 multiplies with R, and equate it to coefficient of x, which is x power 1. So equate it to 1. So again, let me focus on the colors. That's 2, that is R. Over here, that is -1. This is 5 minus R. Equating it to the power of the required term, which is 1. Simplify, evaluate, don't make a mistake. -5 plus R plus 2R. This equals to 1. This is 3R equals to 1 plus 5 is 6. R comes out to be 2. Be happy, you have gotten the perfect answer. Part 3, that is place R where it belongs. So 5C2. This is 1 over x raised to power of 5 minus 2 is 3. And this is 3x square raised to power of 2. 5C2 is 10. This is 1 over x cube. This is 3 square is 9. X2 power 2, that is x power 4. So now double check. Over here, we have x power 4, not this marker, the orange highlighter. This is x power 4. This is x power 3. So this will simplify to x power 1. So now this thing is all good, all clear. And then what are you left with? We are left with 10. We are left with 9. No negative sign issue. 90. So they are asking, find the coefficient of x. If they ask for coefficient of x, we will say it's 90. If they ask for the x term, we will say this is 90x. So the x term has the x in it. Coefficient just has the number. Let's double check. And that is how this thing is done and dusted. So now I'll go to this particular question and I'll pause the recording so that you people can try this particular question out. So the recording is now paused. So now let's look at this question. You can double check your answers. Step number 1, that is writing down the formula NCR, A raised to power of N minus R, B raised to power of R. And let me double check the voice so that there is no confusion. It's all good, all clear. Now over here, I'll write 8CR. A is 2x raised to power of 8 minus r. b is 1 over 2. The constant will remain downstairs. The variable has to be taken up. X raised to power of negative 3 raised to power of r. Again, let me highlight this power 1 over here. This power 1 will multiply with 8 minus r. This power negative 3 will multiply with r. We are looking for term independent of x. So let me just choose the color independent of x. That means the power of x is 0. So now, first of all, the second step, that is gather the powers 1 into 8 minus r, and this is negative 3 into r equal to 0. 8 minus r minus 3r equals to 0. Therefore, 4r equals to 8. Therefore, that's not an 8. 4r equals to 8. Therefore, r comes out to be 2. Perfect. Third step, that is 8c2. 2x raised to power of 8 minus 2, which is 6. And this is 1 over 2x cube, right in the original format. And that is raised to power of 2. So 8c2, that is 28. 2 raised to power of 6, that is 64. This is x power 6. This is 1 over 2 square, which is 1/4. 1 over x cube raised to power of 2. That is 1 over x raised to power of 6. So over here, x power 6, 1 over x power 6 cancels out, and we get a constant term. And let me do the division. That is 4 ones are, 4 sevens are 28, 7 into 64. 7 into 6 is 42, that's 420. 7 fours are 28, that is 448. That is the term independent of x. Hope you got the same answer. That's right over here, 448. So now let's do this question. Now they are asking us that the coefficient of x is 5, find the value of constant a. It's the same thing, same process, except for the fact some unknown thing is there. So again, step number 1, that is NCR, 5CR. This is 1 over ax raised to power of negative 1 raised to power of 5 minus r. This is 2ax square raised to power of r. So always double check the working. So over here, this negative 1 is multiplying with 5 minus r. Over here, this 2 is multiplying with r, and we are interested in the coefficient of x, which is 5. That means coefficient of x, that means x raised to power of 0. So therefore, step number 2, gather powers of x, minus 1, 5 minus r. This is 2 into r equals to coefficient of x. Therefore, x has a power of 1. No, it's not 0, it's 1. So let me write a 1 over here. And let me also add the colors. So that's right over here. And then if I talk about the blue, that's 2 into r. If I talk about the red, that is minus 1 into 5 minus r. So now simplify. Minus 5 plus r plus 2r equals to 1. 1 plus 5 is 6. 3r equals to 6. R comes out to be 2. Step number 3. This is this one over here. The coefficient of x is 5. Now, first of all, let me evaluate this. So 5CR, that is 5C2. This is 1 over ax raised to power of 5 minus 2 is 3. And this is 2ax square. This is 2ax square raised to power of 2. Let's simplify this. This is 10. This is 1 over a cube. This is 1 over x cube. I separate it out. 2a whole square, that is 4a square. And this is x power 4. First, double check. There is no harm. This is x power 4. This is x power 3. So therefore, we are left with an x over here. And then over here, this 4 will multiply with 10. That is 40. And over here, This a square is in the numerator, a cube is in the denominator. So that is 1 over a. I think everything is sorted out. So therefore, overall, the coefficient of x is 40 over ax. This is the coefficient of x. What is the coefficient equal to? That is equals to 5. So 40 over a equals to 5. Therefore, a is 40 over 5. Therefore, a comes out to be 8. And that looks like a beautiful answer. So I think that's all about it on the binomial lecture, binomial expansion, second part, in which we studied two things. One was about some simultaneous equations in which the power was unknown, and something else was also unknown, one of the coefficient of x, and the other one was about the three-step process. So that's all from my side on mathematics with Shahab Yaqub. Take care, everyone.